quick review. Absolute value bars mean what is the distance this number is from 0. What is the distance this number is from 0? It's 2. So that means -2 and +2 are your two answers. This says what is, no, not what is. It says the distance. No. Sorry. What number is 2 spaces away, dang it, from 0? Now, where's the 0? Do you guys see the 0 anywhere? I see the word. It's right there. No, I mean like in here. Where's the 0 in there? It's gonna be. It's in there, but we don't write it in there. Okay, so here, let me give you another example of when we would see an absolute value bars. What about these inequalities? What do these say? It says what numbers are less than 2 away from 0. So what numbers are those? -2 is not less than 2 spaces away from 0. Okay, it doesn't include -2, but it starts at -2. It doesn't include +2, but it starts there. So these are all your numbers right here. This interval right there includes all your numbers that satisfy this. Now, I'm trying to explain to you guys what it means. The way it looks would just be x is less than 2 and x is greater than -2. This is how it looks symbolically. Well, as an inequality. If we look over here at the one that says greater than, symbolically that would say x is greater than 2 and x is less than -2. So how would that look like on my graph? Well, this means what numbers are greater than 2 away from 0. So again, we start at the -2, but we go this way because it says x is less than -2. And all these numbers right here are more than 2 spaces away from 0. All of these numbers right here are more than 2 spaces away from 0. Isn't it easier to look at the symbols and do it? It's because you're used to doing it that way. You don't really know what the absolute value bars mean. Well, I mean, I just told you, but we'll see if you guys remember that later. Okay, now this one. These ones talk a little bit differently. This one says, what numbers are, what's my distance? 2 spaces away from -1. Where do I get the -1? Now this says a +1, but you gotta think the opposite here, because it's actually meaning -1. But you have to write it this way. So here, oh, actually this should say what numbers are less than 2 spaces away from 0 or away from -1. When we go to solve this one, we go x plus 1 is less than 2 and x plus 1 is greater than -2. We flip this sign and we change the sign of the last number to figure it out. And then we would subtract 1 from each of them, and you get your two intervals here. Less than 1, greater than -3. Actually, I think that's just one interval. Because if I go to -3 and I say greater than -3, and I go to 1 and I say less than 1, then it's just one interval right here. So all of these numbers are less than 2 spaces away from -1. See, there's -1, 1, 2, 1, 2. The last one that I want to look at says, what numbers are greater than 2 spaces away from -1? So here's -1. What numbers are greater than 2 spaces? Well, I go 1, 2, and that means anything bigger than that. 1, 2, anything less than that will be greater than 2 spaces away from it. And we can figure that out also algebraically by going x plus 1 is greater than 2, and x plus 1 is less than or equal, or not equal to, but just less than -2. So again, I flipped this sign and I changed the sign of the distance. This one right here is going to be x is greater than 1, and this is going to be x is less than -3. Do our inequalities match our graph? Yeah, they do. Cool. So what I want you guys to do right now is solve all of these as a group. Okay? So I hit pause on the video, let you guys do that. For the first one, the answer is 2, so you would just put a dot on the 2. For the first inequality, you solve that, and it would be x is less than 2.
Yeah, it's not showing up.
Oh, it's not showing up. Hold on one sec. Alright, press unfreeze on the screen. Now you can see it. X is less than 2. And so when you do this one, you are not including 2 in your solution. So you put a circle or you put a parenthesis because you're practicing with interval notation. And you're going to point an arrow that way. And since this is an interval, might as well practice. Because we have an arrow pointing to the left, it goes -infinity to 2. Put parentheses around both of them. Alright, the first absolute value inequality, what does this look like? Well, when you set it up, you go 5x minus 1 is less than 9, and then 5x minus 1 is greater than 9. You're going to get x is less than 2, and x is greater than -8 over 5. -8 over the 5 is the same as -1 3/5. When you graph it, it'll be right here and right here. Now because it says x is less than 2, you go down from 2. Because it says x is greater than the negative number, -8 over 5, and you go left or right. Now this is a bounded interval, and just for practice, I want to show you guys that the interval looks like this: -8 over 5, comma 2, and you put parentheses around it. Alright, last one. You get x is greater than 2, and x is less than -8 over 5. -8 over 5 again is right there, and it says less than, so that means it's going to go to the left. 2 is right there, and it says greater than, so we point the arrow to the right. Your two intervals look like this. It's a union between those two. Because it's pointing to the left, it's a -infinity, and it stops at -1. This one starts at 2. This one right here starts at 2, and then it ends at +infinity. Good catch. Sorry about that. It's not -1. That's -8 over 5.
Does it matter?
Good catch. This should be a -9 right here. That's how we got -8 over 5. Sorry about the mistake. Okay, now I'm not gonna solve these ones or graph them. I just wanted to show them to you. Actually, this one is just the same as the other one. So this one right here, you can't split it up yet until the absolute value bars alone. So you would add 3 to both sides, and you get 1 minus 2x is greater than or equal to 3. But can you guys tell me right now if it's going to be? Oh, thank you. That should be a 6. Can you tell me right now if it's going to be a union or just one interval? It says greater than. That's how you can tell. If you go back and look at your previous ones, the ones that say greater than have unions. Now, if a problem has a 5 right here, or another number multiplying to the absolute value bars, how would you get rid of it? You would divide it by 5. Okay, but this one doesn't have that. I just wanted to show it to you. And that's it for this.
That's it?
Yeah.